everyone, today we are doing another past paper question. This is also from the November 2021 paper 1 exam, and this is question 5, which is all about hyperbolas. Now guys, this type of question is in every single past paper, every single final exam. You can bet money on it that you will be asked to answer these or very similar questions about a hyperbola and then to draw it. Okay, so let's get started. They've given us the equation f of x is -1 over x minus 3 plus 2. Now for 5.1, they are asking us to write down the equations of the asymptotes of f. Now guys, the asymptotes always come from this value and then that value, the plus 2 and the negative 3. Alright, now they have not asked us to classify the asymptotes. We don't have to say which one is horizontal and which one is vertical, but we can. The horizontal asymptote is always the y asymptote, and the y asymptote is always our q value, so the number that comes after the fraction. We don't change that sign. That is just the y asymptote, the horizontal asymptote. And then our vertical asymptote is the asymptote that will give us a value that will make the denominator equal to 0. So if our denominator is x minus 3, which x value, what must x be so that the denominator is equal to 0? Because remember, when a denominator is equal to 0, that whole expression, that whole equation is undefined. That is why we have an asymptote there. Now the x value that will make this equal to 0 is going to be x equal to 3. So that is our second asymptote, our vertical asymptote. Okay, next up for 5.2, they have now asked us to write down the domain of f. Now the domain of a hyperbola is always all real numbers except for where we have that asymptote. So we are going to say that x is an element of real numbers, but remember, it can't exist. The graph does not exist where x is equal to 3. So we have to specify that x can be equal to all real numbers, but not equal to 3, not equal to the value where that asymptote is. For question 5.3, they are now asking us to find the coordinates of the x-intercept of f. Now I've underlined the word coordinates. We need to remember we can't just leave our answer as x equals a value. We have to have an x value and a y value. Those are coordinates. So for the x-intercept of any graph, it doesn't matter what type of graph it is, you can always calculate that by making y equal to 0. So in our equation, it's y equal to -1 over x minus 3 plus 2. I've now made y equal to 0, and now I'm going to solve for x. Now there are different ways in which you could do this. You could multiply each term by x minus 3 straight away, but I actually prefer just taking that plus 2 across, and the opposite of adding 2 is subtracting 2. So I have a 0 minus 2, and then I'm left with that fraction. Now I'm going to multiply both sides by x minus 3 to get rid of that denominator. So I have my -2 times x minus 3 equal to -1. Now from here, again, you can, if you want to, divide by -2 straight away. I actually think that is what I'm going to do. So I'm going to divide by -2. -1 divided by -2 is +1/2. And now I'm going to simply add 3. So I'm going to get to 3.5 as my x-intercept, or you can write that as 7 over 2, or of course 3.5. It's up to you. So the coordinates of my x-intercept are 3.5 and 0, or 7 over 2, or 3.5. You can decide. In 5.4, they are now asking us for the coordinates of the y-intercept of f. And the coordinates of the y-intercept, that is always easier than calculating the x-intercept, because for the y-intercept, all you have to do is make x equal to 0, sub that into your equation, and work out what your y value is going to be. So for y, we're going to get -1 over, it's x minus 3, but now we're going to do 0 minus 3, right? Because x is now 0, and then plus 2. Now when we calculate that, this fraction is going to simplify to 1/3, and then when we add 2 to it, we're going to get 2 and 1/3. Or again, if you prefer, you can write that as 7 over 3, or you can write it as 2, 3 recurring. It is entirely up to you. So the coordinates of the y-intercept are 0 and 7 over 3. or 2 1/3, or 2, 3 recurring. Again, it absolutely does not matter. Both, or all three of them, in fact, are correct. Now, 5.5 is always the culmination of this question, the final question. Draw the graph of f. Clearly show all asymptotes and intercepts with the axes. So you can see I have highlighted my asymptote equations here. We're going to have to draw those asymptotes. We are also going to draw, or plot rather, the x-intercept and the y-intercept. And then we'll see. We might have to calculate some more things for that. Maybe that will be enough. Okay, I'm actually going to put my graph next to all my working. So I'm zooming out a little bit. Okay, let's see. I think I'm going to do 1, 2, 3, 4, 5, 6. Let's do it like that. Alright, now the first thing that you're going to do once you've set up your axes is you are going to draw in your asymptotes. That's always the very first thing that you do. So we have to draw in y equals 2. So I'm going to go to 2 on my y-axis. I'm going to label that as y equals 2, and then we're going to go to x equals 3. So on your x-axis, go to 3, and then you're going to draw a straight line that is completely vertical, like that. That is the line x equals 3. I'm quickly going to turn my asymptotes into dotted lines. Alright, there we go. Those are the asymptotes ready to be used. Okay, next up, I'm now going to put in my 2 points that we've calculated. So the x-intercept is at 3.5 and 0. So my asymptote is at 3. 3.5 will be just to the right of it. Okay, so I'm going to draw my graph going through that point, and then my y-intercept is the point 0 and 2 1/3. So again, my y asymptote is at 2, so then 2 1/3 will be just above it. You don't have to draw it extremely or perfectly. You don't have to plot your points completely or perfectly accurately. It doesn't matter, just kind of draw it in the area of that value, and then we are going to put in our curve. This one should actually be curving out a little bit more to the side. All right, we are going to label that point. I'll do that just now, actually. Our next one here, remember when you are drawing a hyperbola, your graph should go kind of towards your asymptotes. It's not meant to curve away from the asymptotes. It's meant to curve towards the asymptotes. All that's left for us to do now is that we are going to actually just write down what the coordinates of these 2 points were. So we had 3.5 and 0 as our x-intercept, and then we had 0 and 2 1/3 for our y-intercept. In this case, since we have 1 point on each of the 2 sections of the hyperbola, we don't actually have to calculate any other points. So that is it. That is the final graph. And let me just put in here that this was question 5.5. Alright, I hope that that was useful, guys. Please let me know down below if you would like me to work through any other specific past exam questions or any topics that you would like me to cover. And if you're not in grade 12, what grade would you like to see? Which past paper questions from which grade would you like to see? Also, I would really love it if you could give this video a like, maybe leave a little comment, and also, of course, if you could subscribe and tell all your friends about it. Have a lovely day.